results in an automatic strategic power grid planning. First, I would make a short introduction about my research project called Sector Plan. In this project, I developed cross-sector strategic grid planning methods and methods for cross-sector renewal planning and automated grid planning in support of 7 distribution system operators. And the focus of this contribution is the method of the automation of renewal planning results. And I want to demonstrate how important it is to combine the renewal planning and the strategic grid planning. First, I will go on my strategic grid planning and the optimization algorithm. I am using the genetic algorithm, which is based on principles of the evolutionary biology, and therefore we have derived techniques, the selection, the recombination, and the mutation. On the right side, you can see a process schema of the genetic algorithm and the 3 derived techniques. We start with an initial population. Each population exists of different individuals. Each individual is a grid model. And then we evaluate our individuals, and then we start our optimization. In the first step, we select the best evaluated and some random evaluated grid models to build our new base for our new population. And then we use the recombination and the mutation to build the rest of the population. In the recombination, we select different grid models and combine these 2 new grid models. And then we have the recombination, the mutation. There we pick a grid model and change something in our grid to build a new grid model. This new population is evaluated again, and this goes on until we find our best individual. Here we can see on the left side our grid sequencing, and on the right side our fitness function, which we use to evaluate our grid models. On the left side, our grid sequencing, we are transforming our grid to a string of numbers which represent the grid, and the numbers represents changing to the initial grid. So we have the number 0, which means we have no measure, and the numbers 1 to 4, which means we have a line renewal or a new construction of different cable types. Each number of our string is a node combination in our grid. So each node combination is a possible line in our power grid. On the right side, we see our fitness function. We are using our individual or our gene sequence with the power grid model to model our power grid expansion and to determine our grid expansion costs. In the second step, we make an admissibility check and determine penalty costs if we have still violations of technical constraints. So we can build our total costs with the grid expansion costs and our penalty costs. And here we can see our whole planning process. We are making a building up simulation of the support years. So we start with the first support year, and the result of our first optimization is the input of the next optimization, so for the next support year. We are optimizing our operand points separately, so we have the operation point peak load and peak feed in. And we are optimizing only conventional grid expansion measures with our genetic algorithm. The innovative technologies like load management or regulated distribution transformer is a rule-based simulation around our optimization. Now I want to integrate the renewal planning. In this case, we use a time-based renewal planning, but each form of renewal plannings can be used. So we have 2 blocks. In the first block, we do the renewal planning to our actual support year. So we change every lines who has to be changed in the renewal planning with a standard cable tube. This is necessary to simulate the correct actual grid state. And then we have our second block. This is the block who is in the optimization of the genetic algorithm. This block allows the optimization to freely modify the dimensioning of the already renewed cables from 1. So there are no costs in the strategic grid planning. The costs are shifted to the renewal planning. And here we can see a result for a German low voltage grid. On the left side, we can see the conventional measures with our renewal planning, and on the right side, with renewal planning, the colored lines and blocks are the planning measures. We can see on the left side, we need to construct a new line in our second feeder, and on the right side, because the renewal planning has changed some power lines, we only need to renew some lines and don't build a new line. And herefore, I brought some costs. We can see on the left side the only strategic grid planning costs, and on the right side with the renewal planning costs. And we can see on the left side the conventional costs are on like $45,000, and our innovative technologies like our dynamic load management is on $39,000. So we would use a dynamic load management system for this grid. But if we use the renewal planning and the strategic grid planning in combination, we can see the costs of the conventional grid planning is reduced because we don't need all measures we figured out in the strategic grid planning. So we can reduce in this example the costs to minus 70%, and the total cost with the renewal planning minus 12.5% costs. Here we can see the conventional grid planning and the dynamic load management are on the same level. So now we can decide which technology is the best for our grid. And now I come to my conclusion. We have currently a high demand for our planning of power distribution grids due to charging infrastructure for electric vehicle, electric heat pumps, and photovoltaic systems. So we are executing lots of strategic long-term power grid plannings. But it is important, how I showed, to implement the renewal planning into this strategic long-term power grid planning, because only if we implement the renewal planning, we can find the best planning measures and the best planning technologies in our strategic long-term power grid planning. Thank you for your attention. Now I'm open for questions.
Thank you, Mr. Riedlinger. Do you have any questions from the crowd? Any questions? No? Okay, well, I would like to ask a couple of things then.
Yes.
My first question relates to the fact that what is the duration of the process? If you try to run one set of processing in order to identify the optimal structure, what is the duration of that, and can it be used, the calculations, can it be perhaps implemented with SCADA inputted data in order to be applied either online or for dynamic online switching?
No, they're not. But the simulation is based on the grid and switch like between 5 minutes and 1 hour to simulate one low voltage grid for 3 support years till 2050. So we simulate in our cases 3 support years, 2030, 40 and 50 with electric vehicles, heat pumps and photovoltaics.
Okay, thank you very much. Any further questions from the crowd? No? Thank you very much again for the presentation.